seconds.
Okay, good morning, everyone. How did the homework go? Any questions? Okay, so if you don't have any questions, we're gonna start section 10.3 today, polar coordinate. Now, I did not put the notes on Blackboard because the book is very clear about it, so you can look up the book. And if you don't like it, I will put up the notes later on. So it's really up to you. So polar coordinate. First, let's see what the idea is. Okay, let's see if this focuses better. Not much better. All right. We are used to something called the Cartesian coordinate. Cartesian coordinate. What's the idea of the Cartesian coordinate? The Cartesian coordinate, the idea is the following. You have a point in the plane, you have a point, and what you want to do is to locate this point. So suppose you have this point and you want to tell me where this point is. So you associate to every point two coordinates, but we call them the Cartesian coordinate. Their job is to tell me the position of this point in the plane. So the x tells me how far to the right I need to move, that's the x coordinate. And the y will tell me how much vertically I have to move. And that's what we call the Cartesian coordinate. So it's a way to locate a point in the plane. Now, there is another way to locate a point in the plane that we are going to call the polar coordinate. So since the idea is basically to locate point, that's what the Cartesian coordinate means. And Cartesian is actually after Descartes. That's where the word Cartesian comes, and Descartes was the person who came up with the idea of to locate a point in the plane, we can locate it by studying the x and y distance. So it wasn't really an old idea. It was sometimes in the 16th century that people start thinking about locating point by using Cartesian, by using coordinate. So today we're going to do locate point in the plane by using another way, another representation, and that's where the polar coordinate will come from. So how are we going to locate point? So we take a point. The way we're going to do it is as follows. We will fix a point. We call it the origin, and we will fix an axis. It's usually like the positive x-axis, and we call this the polar axis. So we fix a point and an axis, and we take an arbitrary point in the plane. And my job now is to locate this point, to give you a way to tell you where this point is. So the way we will describe how the point is by giving you the following two information. I will tell you how far is the point from the origin. So I'm going to call r the distance. That's what r is, the distance from the point that I fixed to the point P. So that's a fixed point. Then I will tell you the angle between the polar axis, which is for you the positive x-axis, and the line OP. So that's my angle theta. So theta is the angle. Very specific angle, not just it's between the positive x-axis, that's important, the positive or the polar axis in this case, so the polar axis and OP. So that's my angle theta. R theta, the pair r theta is called the polar coordinate of the point P. So r theta will be given a name, and that will be called the polar coordinate. So it's really a different way to locate point in the plane. That's really what polar coordinates, which are useful in a lot of scenarios. So here I will write r theta. R is from 0 to P, and theta is the angle between the positive x-axis and OP. Now theta could be positive or negative. Positive, we're moving counterclockwise. Negative means we're moving clockwise. So theta will mean what the angle is. The important part is that it's measured. It's measured from the positive x-axis. It's not measured from anywhere else. We start from here and move. Now, some convention before we start taking examples. So those are convention, things that we usually accept and we work with. R equal to 0, regardless what theta is, will correspond to the point of the origin. So when I say 0 pi, I mean basically the origin. That's what R equals 0 means. The second one, which is more the interesting one or the important one, is we will allow R to take negative value, even though my definition here is anything but negative. So what we're going to do, we extend the meaning of R. We extend the meaning of R. That's why it's by convention. We extend the meaning of R to allow R to be negative as follows. So what does it mean to have a negative R? A picture, as I say, is worth a million words. So I will describe by a picture. What does it mean for R to be negative? So first, let me sketch the following point. Suppose I have the point in polar coordinate 2 pi over 3. I will sketch this point. That's the R for me, and that's the theta. So let me sketch this point. So I'm going to start from here. The point is theta is pi over 3. It means I start from the positive up to here, pi over 3. That's my angle. And my point is 2 units away from O. So that's my 2. And that's the point with polar coordinate 2 pi over 3. Now, what does it minus 2 pi over 3 mean? So here I'm letting R to take a negative value. Minus 2 pi over 3 by definition is the following point. It's the point which is symmetric to the positive R with respect to the origin. That's the point minus 2 pi over 3 in polar coordinate. So that's the convention we use. If R is negative, minus 2 pi over 3, which point it represents? It actually represents the point which is symmetric to the positive one with respect to O. So minus 2 pi over 3, that's geometric what it is. So another way you can think about it is that minus 2 pi over 3 is the same point as 2 and what? 2 and what? I want the answer on chat if you can understand the picture. So minus 2, we're allowing R to be negative. Minus 2 by definition is the point that is symmetric to 2 pi over 3 with respect to the origin. So you just take this point and you go right there. That's what it is. That's the convention. Now I'm telling you that it's the same as the point 2. It means now my 2 is positive. It means to represent the distance. And what? So Sarah is telling me 2 and minus pi over 3. I have an issue with that because what is 2 minus pi over 3 is? I'm going to draw it in red. Minus pi over 3, it means this way. And 2 minus pi over 3 in polar coordinate will be this point. So this will not take it. What is, you think the point, and somebody is telling me 2 pi over 3. Is she right? I don't know where she get the 2 pi over 3 from. So let us see, what's 2 pi over 3 and 2? I'm gonna draw everything you guys tell me till you figure out what am I talking about, if we're right. 2 pi over 3, it means you take pi over 3 and you add another pi over 3. So that's 2 pi over 3. So it definitely doesn't work. That's 2 pi over 3. Now, the last answer was 4 pi over 3, and this one is, yeah, now this one is the correct one. That one is correct because basically, what's the angle from here to here? So if we think geometrically, this angle is up to here, it's a pi over 3, but how much we're adding? We're adding pi to it. And that would be the correct answer. So it's going to be 2, and I will draw it right here, pi over 3 plus pi, which will give me 4 pi over 3. So the point, minus 2 pi over 3 is the same as, that's okay, yeah, that's okay. So minus 2 pi over 3 is actually the same thing as the point, 2 pi over 3 plus pi. So let us sketch some of those points so you can have some kind of really, feeling for it. So I will do the following. I'm going to sketch several points in polar coordinates. So will give you some points. So the following points are in polar coordinate, and we will sketch them to have a feeling of them. So the following points are in polar. So every time, at least in this section, I will be very precise whether I'm talking about Cartesian or polar. So the following are in polar, sketch them. So we will sketch several points. And the first point is, I will start with an easy one. Suppose I take 2 pi over 6. That's polar. It means it's positive r, which means that's telling me the distance that the point is from the origin. Pi over 6 tells me the angle it forms. So we sketch this, we start, that's my polar axis. Theta is pi over 6. I start from here, pi over 6, which is also 30 degrees. And then I take 2 units away. So from here to here, that's a 2. This point is 2 pi over 6. Another point. So I will sketch several points. So we will, and suppose I take a 2 minus 3 pi over 4. 2, that's a positive number. So I don't have any issue. I start here. Now, minus 3 pi over 4 means I have to move the clockwise direction from the positive x-axis. That's crucial. So minus 3 pi over 4 is like minus 145 degrees. So this is minus pi over 2. That's the theta. Minus 3 pi over 4. And then I need 2 units. That's the r. And so this will be my point. So that's my point, 2 minus 3 pi over 4 in polar coordinate. Minus 3 pi because I move this way. Now I will draw a point with negative r. So because we will use them, they are important for us. So I will just put a minus 2. There is nothing really important about that. So that's my r. R is negative. And I will pick an angle. Let me pick 2 pi over 3, let us say. Let us draw this point. So how I will draw this point? The way I will draw it is like this. I first take the positive one, and then I take the symmetric of it with respect to the origin. So that's the easy way to do it. The positive one, it means I start with 2 pi over 3. So 2 pi over 3 is 120. So I start from here, 2 pi over 3. So I'm not drawing the point yet. And then I will go 2 units. This is the positive 2. So from here to here, that's the positive 2, 2 pi over 3. Where is the negative 2 is? You take absolutely the point right here. It's the symmetric of it. So this point is in polar minus 2, 2 pi over 3. So when you have a negative r, the best way to sketch it is first you take the positive, and then what you do is you take a symmetric with respect to. That's what a negative r means. So now so this point is the same as, I'm going to go back to the idea, so it's the same as the point 2, and again, what this angle is. So there are different representations of a point in polar coordinate. One is minus 2, 2 pi over 3, and the second one is 2 and what? I want to put 2 here, what the angle should be. The angle should be all the way plus the pi. That's what my angle should be. And so my angle should be, let me write it here, it will be 2 pi over 3 plus pi. So that's really what it is. You're adding pi. So this will give me 2 pi plus 3 pi, 5 pi over 3. Okay. And let us always try to represent our angles in radian because calculus work in radian. So I know that you're putting answers in degrees, but I prefer them in radian. Okay. So I'll do one more point before we proceed. Okay. Let me take another piece of paper. So one more was negative. Okay. So let me put, for example, the minus 2 minus pi over 4. Okay, I will draw it, but I don't want to draw it. I will ask you, in which quadrant do you think this point would be? So I give you a minute to think about it, and I would like you to tell me in which quadrant this would be. Think a little bit by yourself, so you know exactly which quadrant do you think this point will end up being. Question addressed to everyone, so I can make sure you guys understand the negative r. So is it going to be here, 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 here? Use chat. Okay, Lori, tell me 3. Do we agree with Lori? Okay, somebody said 2, 2. Yeah, 2 is the right one. Let us see what. What do you sketch first? This piece. When I sketch this piece, where am I? I start minus pi over 4. I am right here. That's the one with the positive 2. So this point here has, for polar coordinates, 2 minus pi over 4. Where the one with the minus will be. You take it, and you take it symmetric with respect to the origin. So this point right here in polar will be minus 2 minus pi over 4. That's what this point would be in polar coordinate. Okay, I will give you one more chance, and then I will have to move on. So let me pick a point, minus 2, 5 pi over 4. And my question is to you before we draw it, because that's the only way I know whether you're following me, in which quadrant this would be. In which quadrant this would be. So draw it in front of you and answer the question, in which quadrant this would be. Okay. Nobody figured out? Quick, you guys should figure it out this quickly. Top right, it means top right here. Absolutely, that's what it is. So first, I draw 2 5 pi over 4. 5 pi over 4. 5 pi over 4 will put me right here. That's the positive one. So that's the 2 5 pi over 4. So I want the minus 2, it will put me right there. And that's the minus 2 5 pi over 4. Okay. Now, the second remark is the following. Cartesian coordinate. Every point has, in Cartesian coordinate, every point has only one set of Cartesian coordinates. Cartesian. It means if I tell you this point is 2, 3, these are the only Cartesian coordinates they have, because 2, 3. You cannot have a different representation for the point in Cartesian coordinate. Polar coordinate is different. A point can have different representation in polar coordinate. So the polar coordinates are not unique. Every one point can have infinitely many Cartesian polar coordinates. So let me ask you the following question. I will take a point that I take 2 pi over 3. So I know my point, that's 0, that's a positive, and 2 pi over 3, so I took a simple point, and it's right there. So my question is, give me another representation of this point with 2 other different representation where the R is positive. What do I mean different representation? 2 other numbers, this cannot change because that's a distance basically, 2 other numbers that represent the same point. Who can give me 2 other numbers or 2 other pair of value that represent the same point? So I am in polar. One representation is 2 pi over 3. So who can give me another representation of the same point?
2 negative 300 degrees.
I said I want radian because you guys have to work with radian.
Okay.
So tell me how you got it, and then I will.
Well, I knew that pi over 3 is 60 degrees. So I just did the count or the clockwise version. I just subtracted 60 from 360.
So you took minus 2 pi.
Yeah.
Yeah, that's as simple as that. So your classmate took pi over 3, and then tell me, okay, I can go all around minus 2 pi. We're hitting the same point. Or plus pi, right? Either way would work. So another representation will be pi over 3 plus 2 pi, because you don't really change. If you take pi over 3, of course, and you add 2 pi, you're back to the same point. Or 2 pi over 3, sorry, minus 2 pi. Infinitely many. You can add 4 pi, 5 pi, as many as you want. Now I want another representation for the point with a negative r. So I will draw the point again. This is the point right here. That's 3 pi over 3. And this is 2 pi over 3. I want another pair that represent the same point, but the r is negative. So what would be that representation?
Would it be negative 2 pi over 3 plus pi minus pi? Or it would be plus or minus pi?
You have to be very direct. So let me listen. So minus 2, that's the suggestions. And what's the angle? The angle is the one that's going to matter.
Pi over 3 plus or minus pi, because we need to go 180 degrees.
Let's do plus pi first. Okay? All right. Do you agree with him? I don't know. Anybody agree with him? Nobody telling me yes. So yes, very good. So let me tell you what's the thinking behind it. Let me look at this point. Right there. That's the easy way to find the r negative. Give me the coordinate of that point with a positive 2. if I put positive 2, what will be this point? As your classmate said, pi over 3 plus pi. It's this point right there. So the point opposite to it would be minus 2, that's the opposite to it, pi over 3 plus pi. That's another representation. So that's minus 2 pi over 3 plus pi. Absolutely correct. So that's really how we can come up with plus pi. So the easiest way to find the negative is actually say, you know what, if I know the coordinate of the point opposite to it with respect to origin with a positive r, the minus will bring me back to my point. So I start playing the game here. I find this point, and then I said the minus, it will bring me to that idea. That's really how the plus pi that your classmate, or he said, okay, you take pi over 3, and you take minus pi, which will do. So one problem with polar coordinates, it's not a problem, but one issue is that a point can have different representation. Actually, it can have infinitely many representation. As you get the minute you start adding 2 pi's, you're getting the same point. Now, where are we at? So we have a point in a plane, and every point now has 2 sets of coordinates. They have Cartesian coordinate and they have polar coordinate. So let us say this is my polar axis, this is my origin. And on the top of it, so that's my polar plane where the point, that's the angle, that's the arc. And suppose on the top of it, I put my Cartesian plane. So this line is the positive x-axis and the polar axis, and this is the regular y-axis. In this situation, and I take a point P right here. That's a point P. Now every point have 2 sets of coordinates because we introduced a new one. So it has 2 sets. It has the Cartesian coordinates, which are the x and the y. That's how I can tell you where the point is. I can tell you the x or the y. But I have another way of telling you where the point is. I can give you the r and the theta. So we're locating points in a plane now in 2 different ways. So the x is x and the y is the y. The theta is right there. And the r is right there. So now the natural question is, if I know x and y, how do I know the r and the theta? And if I know r and theta, do I know the x and the y? So right now, I will just do one of them, the very easy one. So the question is, suppose I have a point P, and we know the polar. So every point now, there is 2 ways that you can represent a point. You can either by Cartesian or coordinate or polar. So suppose we know the polar, r and theta. How to find the Cartesian? X and y. Okay. So, okay, back to simple trigonometry, because I want you to memorize this by using simple trigonometry, and then I tell you that this could be generalized. So simple trigonometry, if I know the r, and let us assume now to understand the picture and to be able to memorize this stuff, let us assume r positive, it's the regular r. And theta is this angle. So what's the relationship between x and, suppose I know r and theta, how can I find x? Do you think this is easy or hard?
Easy. I'm pretty sure x and r are essentially the same thing.
What?
In terms of distance on the x-axis.
Absolutely not. How?
If you're
from here to here.
Yeah, and the x value for that coordinate, if we were using the Cartesian plane, would be 2 if r was 2, if that's what we're saying.
No.
No? Okay.
No. This is r. No, sorry, no, period. Who can give me x in terms of r? This is it's a right triangle, and that's a hypotenuse. Are you with me? X is the leg of the triangle. X cannot be R. X is the leg of this triangle. Okay, so I want you to use basic trigonometry. What is the X in terms of R and theta? If I give you R, I give you theta. And this is a right triangle. Can you give me the X quickly? It's a right triangle. I know the hypotenuse, I know the angle. What's going to be my X?
Would it be?
I don't, Mark, you are right, but I don't know why. What do I know? I know R and theta. I want to find the X and the Y. So even though your formula is correct, but I don't know why. I know the R. I know theta. I want to find X. How would I find it? Yes, James is correct. Because he used, this is a triangle. I give you this, and I give you the angle, what's X? Let us watch. What's the cosine of theta? I know theta. I know theta. What's the cosine of theta? It's the adjacent over the hypotenuse. So this will give me what for X? X is R cosine of theta. That's my X. Now the Y. What is the Y? This is the Y, and this is the Y. Again, I would use basic trigonometry. What is the sine of theta? The sine of theta is the opposite over the hypotenuse. It means the Y is the R sine of theta. Very important, crucial formula, period. So
if you solve for X first, could you use the Pythagorean theorem to solve for Y?
My answer will be yes, but it's very important totally know those formulas. I mean, crucial. They are very important, okay, to know. They are the formula which gives you the relationship between polar and Cartesian. So even though my answer to you is right, but that's the one that I want you to use, simply because I want you totally to memorize them. They are very important. So my X, and these are easier to use than what you suggested, even though what you said is correct, but these are way, way easier to use. And Y is R sine theta. Okay. Now, I said I'm going to stop right there, and you guys will have to go and take the quiz. I will take you from there next time. So next time we will go from polar to Cartesian, but I have to talk a little bit more about that because of the suggestions that you guys make. So I will have to talk a little bit more about it. For now, I want you to go and take your quiz. All right, good luck, guys.